Let's remind each other the basics of differential calculus. Question number 1. Differentiate the following from first principles. The term first principles is written in capital letters to show emphasis. You cannot differentiate in any other way. You are supposed to use first principles. That is what the instruction says. Our formula, the formula will be provided in the examination paper, is that the derivative of an expression is always equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. That is the formula for first principles. What the formula means is that in place of x, we substitute x with x plus h. In place of x, we substitute x with x plus h. That is the first part of our formula, f of x plus h. It basically means you substitute x with x plus h. Our expression that we are differentiating in question 1, we have 2 minus 3x squared. So 2 minus 3x squared, the position for x is going to be taken by x plus h. So 3x squared will now become 3 factor of x plus h squared. That's what we mean by f of x plus h. It simply means in the expression, remove x and substitute it with x plus h. Once we do our substitution, we go ahead and simplify our expression. The word limit and h approaches 0, they must be written. That is part of the notation. Without them, this expression will mean something different. Now, important, most of the time when we have an expression that is a negative sign, a number of learners get it wrong because of that negative. So x plus h squared means x plus h multiplied by another x plus h. Then in the second part, when I remove those brackets, notice that the 2 becomes negative and the 3x squared is going to be positive, because the negative and the negative makes it a positive 3x squared. Then when I remove these brackets, I have to first of all make sure that I do the multiplication before I do the subtraction. So because of that, I'm going to keep the negative 3 outside, and then we use the FOIL method to simplify these brackets. So that will be x squared plus 2xh plus h squared, then minus 2 plus 3x squared. Then from there, we're dividing this by h as h approaches 0. So everything that follows after this is basic algebra. Just to make sure you are careful in handling negative numbers, because they are culprits in maths. So if I multiply the negative 3 times x, that would be negative 3x squared. The next term gives us 6 minus 6xh. The next one gives us minus 3h squared. Then minus 2 plus 3x squared divided by h as h approaches 0. After simplifying my expression to this level, you can do a quick check to make sure that your answer is correct. When you get here, the original terms of your expression, which is 2 and negative 3x squared, they subtract each other to become 0. So there is 2 here and minus 2. 2 minus 2 is 0, minus 3x squared plus 3x squared. that gives me 0 as well. When the original terms of my expression are removed, then what remains there are terms that contain h. They definitely must be in terms of x and h. H must appear in every term because the next thing after this is factorization. So for factorization to be possible, h must be a common factor. If it happens by any chance that h is not a common factor, then it definitely means there is a mistake in your calculation. H must be a common factor because we divide this expression by h as h approaches 0. So the h that we factor out and the h that is the denominator, the two divide each other. The h that remains there becomes 0 because the h is approaching 0. So if you put 0 in place of h, you are going to get minus 6x minus 0. So the answer to this question is minus 6. That is my question after differentiating using first principles. So we have to emphasize this. These are very easy marks that everyone is supposed to get, but most of the time we notice that learners make mistakes, especially with the negative sign. I have a negative here, so I'm going to keep the negative outside. Then you do this multiplication first using the FOIL method. When you are done, then you multiply the negative 3 with the numbers that are inside. When you are done, make sure that you check that the original terms in your expression subtract each other. The remaining terms must have h as a common factor. You factor out h, and then the remaining h becomes 0, and that completes your answer for that question. We have differentiated question 1 using first principles, and our answer is negative 6x. But question number 2.1. So after the first principles, the next part of differential calculus requires you to use differentiation rules. Now, what we know is that if you are given f of x is equal to ax to the power of n, then the derivative of f of x is equal to an multiplied by x to the power of n minus 1. This is the formula that we apply in differentiating using differentiation rules. Now, number 2.1, we want to differentiate. F of x is equal to 2x to the power of 4 minus 3x plus a squared. We want to differentiate this expression and determine the derivative. So in this expression, the formula that we are applying is applicable to one term at a time. So the coefficient is the value for a, the exponent is the value for n. In the next one, a, and also the exponent is n. The last term, we are differentiating with respect to x. And if that means if there is no x in that term, it is a constant. Therefore, it will become 0. If you are differentiating with respect to x and the term that does not contain x, then it will become 0. So our answer for number 2.1 is going to be a times n. That's 2 times 4. So 2 times 4 is equal to 8x. Our exponent is n minus 1, which is 4 minus 1. So 4 minus 1 is equal to 3. Then the next one, there is no exponent indicated here. we know that there is 1, a divisible 1 there. So a is negative 3, n is 1. A times n is 1 times negative 3, and that gives me minus 3x. Then the exponent is 1. If you subtract 1 minus 1, that will give you 0. Then the last term becomes 0 after differentiating. This is our answer. Notice in the second term that we have an exponent 0. So any number with exponent 0 is equal to 1. Therefore, the answer is 8x cubed minus 3. The x to the power 0, there is no need to write it. So the answer is done. That is 2.1. In number 2.2, very much important for us to please understand this. We want to differentiate this expression, and we are using the same rule, 2x cubed minus the square root of x divided by x. We want to find the derivative of this expression. So for this rule that we are applying here to work, we must clearly be able to see which one is a, which is the coefficient, and which one is n, which is the exponent. So for that to take place, we have to make some observations first. Number 1, make sure that in your expression there are no brackets. The differentiation that we are doing now does not differentiate brackets. You do more methods when you go to university on how to differentiate brackets. For now, we must have no brackets. If an expression has brackets, you simplify the brackets first. Then the second one, you must make sure that your expression does not have square roots. If there are square roots in the expression, we have to change them using the laws of exponents. So let's say, for example, we have b root of x to the power of a. Then this is the same as x to the power of a over b. This is the rule that we use to change square roots in our expression. Then the third rule that we apply is that you must make sure that your expression does not have variables in the denominator. No variables in the denominator. The variables that I'm referring to here, we are talking about if you are differentiating with respect to x, then you can't have x in the denominator. So if there is x in your denominator and you are differentiating with respect to x, then we must use the laws of exponents to change it. Let's say, for example, we have a over x to the power of n. Then this is equal to ax to the power of negative n. This is the law of exponents that we use to deal with variables in the denominator. So now let's look at question number 2.2. We notice that we have two problems there. The first one is that there is x in our denominator. We must remove it from there. The second one is that there is a square root. We must change that square root and express it differently. A square root is the same as x to the power of 1 over 2. Then this is divided by x. Now, to do that, if there is one term in the denominator, we have x only. Then we have two ways in which we can simplify this. The first method will be you separate this expression into separate fractions. That means you divide each term in the numerator by the same denominator. So this is going to become 2x to the power 3 divided by x, and then x to the power half divided by x. Then we simplify the expression. 2x cubed divided by x will equal to 2x to the power of 2. Then x to the power half divided by x, that will give us x to the power of negative 1 over 2. Remember, when you divide the same basis, you subtract the exponents. So the bottom one is exponent 1. Half minus 1 gives us negative half. Now, after we have simplified, after simplifying the expression, we can now be clear about which one is a, which one is n, which one is a, which one is n, and therefore are now in a position to write down the answer for this question. So now the answer, we're going to multiply a times n, that's 2 times 2. It gives us 4x. The new exponent is n minus 1, so 2 minus 1 gives us 1. Then in the middle here, negative half times negative 1, it gives us plus 1 over 2x. Then if you subtract minus half minus 1, it gives us minus 3 over 2. This is our answer for that question. We have differentiated this expression with respect to x. So once again, the critical part of such questions is making sure that you know how to simplify the expression before you differentiate. Notation is also important. I keep the expression dx, but in the last part of it, I don't have it because I have now differentiated. So if you can remember the square roots, the square root of x is the same as x to the power of 1 over 2. The cube root of x is the same as x to the power of 1/3. The fourth root of x is the same as x to the power of 1 over 4, and so on. This is the law that we use to change square roots. So in that way, our question number 2.1 and 2.2 are answered. Right, question number 2.3. We want to find dy dx. Now let's remind each other something important here. Our expression is yx minus y equals to 2x squared minus 2x. This is the expression that we are differentiating, and they said x is not equal to negative to positive 1. This one here does not mean you must do something about it. It is just a condition, especially if the expression is a fraction. Right, we have to remember that when you are working with fractions, if the denominator is equal to 0, then the fraction becomes undefined. So in this case, x must not equal to 1, so that the denominator may not become 0. That is basically what it means. But in terms of calculations, there is nothing that you are going to do. You are simply going to work out the expression as usual. Now, important in this question, remember when you answer a question, make sure you learn something from it. We want to find dy dx, or maybe let's change it a little bit and say dx, or anything. Let's say we want to find dp dx. Now, what it means that this expression here means your equation, you must have y as the subject of the formula. In the second one, the subject of the formula is a is equal to, then the equation is given in terms of x. If we say dp dx, it means p must be the subject of that formula, then we can differentiate. So I want to find dy dx here. Before we differentiate, we must make sure that y is the subject of the formula, and y is appearing in two terms. So to make sure there is one y in the question, we use factorization. We factor out y from the first two terms, giving us y factor of x minus 1. is equal to 2x squared minus 2x. Now I have, I must also factorize the right hand side, but I've left it as it is for now. Just follow where it's going. Then from here, to make y the subject, we divide both sides by x minus 1 and also divide here by x minus 1. So that will give us y as the subject is equal to this whole expression, 2x squared minus 2x over x minus 1. Now, if you remember, when I was explaining number 2.2, I said you must have no variables in the denominator. And we said that if a denominator is x, for example, let's say I've got this expression, then I must rewrite this as ax to the power of negative n, so that I can then apply the differentiation rule. Now, in a situation where there are more than one terms in your denominator, if the denominator is more than one terms, you must use factorization. You can't put negative exponents to the denominator, to the terms in the denominator anymore. We must use factorization. From the numerator, there is a common factor of 2x. So we factor out 2x, remaining with x minus 1 in brackets. Then our denominator is x minus 1. Then after the factorization, you divide the denominator and the common factor that we have. So those two, x minus 1 and x minus 1, they are divided, giving us y is equal to 2x. After making y the subject, only then do you go on and differentiate the expression. So the derivative of this expression is equal to 2. So should you agree with me, we can see that differentiating the expression itself is not a problem, but we must make sure we know how to simplify it, because simplifying the expression is important before differentiation can take place. So that's number 2.3. This kind of questions, make sure you have got the right subject or formula in that expression before you differentiate. Right, the last question, question number 3. Now, this is a very common type of questions in calculus. They may change the way they ask though, but what we are interested in here is the idea of the equation of the tangent to a curve, the equation of the tangent. So for us to determine the equation of the tangent, we need two pieces of information. So the first one, we need a gradient. We need to know what is the gradient of the line, what is the gradient of the tangent. Then secondly, we also need to know the point of contact. What are the coordinates of the point where the tangent is touching the graph? Those two will help us get the equation of the tangent. Then how do we find these two items? Very much important. The gradient, for us to be able to find the gradient comes from the derivative. Now, if you go back to Introduction to Calculus, you'll remember that the derivative is the rate of change. And the rate of change is basically the gradient. So the derivative is the gradient. You differentiate the expression and determine the derivative. That derivative will lead you to the gradient of the line. It is very much important to understand the derivative is the gradient. So we differentiate the expression, then in the derivative, we substitute x with the x value where the two graphs are touching. That will give us the gradient required. And again, on the gradient one, the gradient of the tangent and the gradient of the curve, they are equal at the point of contact. That is the concept here. In the part 2, we need the point of contact. Normally this one is given, or they give you information that can help you find the point of contact. So let's look at what we are told here. The first one, we are told that from the information provided, we are told that f of 4 is equal to 5. In functions, this means when x is equal to 4, then y will equal to 5. Therefore, 4, 5 are the coordinates which are on the graph. And that is our point of contact in this case. Then the first one, which is the gradient comes from the derivative. If you look at what we have here, we are given the derivative, and then we have x is equal to 4. This means the gradient at x is equal to 4 is equal to 7. So this leads us to what we need. The gradient is given, it is equal to 7. Now with that information, we can compile the equation of the line. From the general or the standard form of a linear function, y is equal to mx plus c. Now in this equation, y is equal to m is the gradient, which is 7. So y is equal to 7x plus c. Then using the coordinates of the point where the two meet, we can then calculate the value of c. So y is equal to 5, x is equal to 4. So this is 7 times 4 plus c. That will give us the value for c. So 5 is equal to 28 plus c, which gives me c is equal to 5 minus 28, which is equal to negative 23. Now that we have calculated c, we got the gradient, we can safely say, therefore, the equation of the line y is equal to 7x minus 23. This is the equation of the tangent with the given details. That is our question number 3 answered. Right, we have answered the whole question. This is from one of the past examination papers, a typical examination question on differential calculus. So quickly, just a reminder of what we have emphasized. In question number 1, when you are doing the first principles, be careful with negatives in that expression. We have f of x is equal to 2 minus 3x squared. So when we substitute the x with the x plus h, we must then be careful how we remove these brackets. We do the FOIL first, then after that, that's when we multiply by negative 3 to get our simplified expression for f of x plus h. That negative, it messes up our performance a lot in our exams. Please be careful with how you simplify expressions when given negative numbers. Then in number 2, important items to remember when you are working with differentiation rules. Now you must make sure that your expression does not have square roots. So that means I must get rid of square roots, not by removing them literally, but by expressing them in a different way using the laws of exponents. So b root x to the power of a is equal to x to the power of a over b. So if I get, for example, the 5th root of x to the power of 3, then I can express this as x to the power of 3 over 5. This is done to be sure which one is the coefficient and which one is the exponent. Then also to remember, make sure that in your expression, there are no brackets. If there are brackets, then you must remove the brackets and simplify the expression before you differentiate. Then the last one, you must make sure that there are no variables in the denominator. No variables in your denominator. If there are variables in the denominator, then you must use the laws of exponents to simplify the expression. A over x to the power of n can be expressed as ax to the power of negative n. This is how we get rid of variables in the denominator. Now, if there is, let's say there is a over bx, this is another issue, and I want to express this one differently. The b stays where it is, so a over b as a fraction is the coefficient. Then you would move x and make it x to the power of negative 1. And remembering that this method does not work if there are more than 2 terms in your denominator. If there are more than 2 terms in the denominator, then it means you must factorize the expression first before you differentiate. Then the third one, we reminded each other that when you are working with the equation of a tangent, there are 2 pieces of information that you need to be able to answer it. You need the gradient, and this gradient comes from the derivative. The derivative of the function gives you the gradient. You differentiate, then you substitute x with the x value that is given. Then that will give you the gradient. Apart from the gradient, you need the point of contact. These are the coordinates of the point where the graph, the tangent is touching the curve. Those coordinates are used for determining the value of c. Once you do that, you can now compile the equation of the tangent. This is differential calculus, basic concepts that we can all manage and make sure that we get full marks for this section.